All right. So we're going to talk about object-oriented programming, and this contrasts with the stuff that we've done so far, which is mostly scripting, right? So when you're doing your homework 2 assignment and you've got your rock, paper, scissors game or your command line choose your own adventure type thing, you are doing scripting where you're doing things. And this is a lot of the stuff that you learned in Python as well, where you want to check like, oh, is a number divisible by 5? Then you write a script and you get that done. Scripting is doing stuff with code. And so in terms of what's next, we want to be able, oh my gosh, how did that come up? No, advance the slide. There we go. We want to be able to build something. So instead of just doing things, we want to build things. We're going to build objects in code. So this is one of the questions on the exam of what's an object, an instance of a non-primitive type. We want to build those. We want to build structures in code that allow us to break things up and allow us to have structures that do specific things. And also allow us to connect it to other objects. We'll look at how do we, like, what sort of properties do these things have, and so on. So again, objects being like a pencil or an apple or a bag. Like these are objects. We can look at that. Like we can look at the document camera and be like, that's an object. But somewhere in the people who made this Lumen's Brighter Teaching branded object, there's like specifications for it of this is how we're going to manufacture this document camera. And so we're going to build these specifications and then actually be able to construct them so that we've got things in code we can do something with. And in this, it's really going to be the case that we're the designers. So as I do examples in front of the class, I'm making choices to say, this is what this object is going to look like. When you go and do your homework, you can make different choices. So we're going to look at, here's the basics of object-oriented programming, but in the assignments, it's really, so homework 3 especially is going to be, you go look for data and find data to make classes about. And there's a lot of decisions that you have to make. And so you're the designers. Coding is like the decisions you make will affect the final project. And so it's for that reason that I see this part of the class as super creative, right? So there's not necessarily like, we need to have a class that meets some specifications, but in terms of which specifications and how to represent them, that's where you come in, where you have to design it and be creative in that way. So the outline includes, we'll go over the 4 principles of object-oriented programming today. We'll look at classes in Java, kind of bringing in all this terminology, things we can do with it. Then we'll go into inheritance of building a family tree of classes. And we'll look a little bit about parameterization and generics. And then maybe we'll get into functors and stuff like that. In terms of this unit is super big and there's a lot of stuff that we need to cover. And so I'm breaking it into sub-units. So the first sub-unit, which we start today, that's going to be classes, where lab 4 will be about classes and constructors. Let's look over at the schedule. So lab 4 is going to be classes and constructors. We've got, depends on how fast we go, we've got a few days of class before we get there. And then we'll talk about inheritance, and then we'll do lab 5. and then genericity and that stuff. And then we'll have the exam. So that's kind of where we're headed for the moment. So lab 4 and homework 3 are part of this subunit. All right, and then I'll talk more about homework 3 once we actually like talk about classes so that it starts to make more sense. Okay, so we need to talk about the principles of object-oriented programming. Object-oriented programming is a style of how we write code, and it helps us do 4 things. Those 4 things are encapsulation, abstraction, inheritance, and polymorphism. Those are all super big words. What do they mean? Encapsulation broadly means we hide some details while allowing things to work under the hood. Abstraction involves looking at things generically, so kind of like rising above and say, this is how it works in general. You don't need to worry about these little details. Inheritance involves allowing us to extend the functionality. So we make things, and then later down the line, we can say, okay, I want to base what I'm doing here on what I did over there. And so we can actually connect those in code that allows us to extend this functionality and use other properties that we've already worked with. And then polymorphism is allowing us to reference things with different types. And so an example that we've seen so far is overloading. So remember on one of the first days when we wrote like a max method and we found the max of 2 things versus the max of 3 things, that's overloading. And so that's a type of polymorphism. Right, we'll talk more about each of these things. So for encapsulation, we tend to view, with encapsulation, we want to view an object as an atomic unit. So if you think about an atom, it's got protons, neutrons, and electrons, right? And generally, you can't break, like an atom is the smallest unit of matter. Like you can't break down the atom anymore unless you want to like create a huge explosion, right? So it's an atomic unit where the user doesn't, if we've got an object in code, the user doesn't get to dissect it. Like that's the unit that they have to work with. And this involves information hiding. So encapsulation is all about, I'm going to let you use stuff, but not let you play around with everything. So I've got a story where I used to have this Microsoft Surface computer and the network card crapped out on me. And I went to the IT and I was like, hey, I can't connect to the internet anymore. Can we fix it? And they looked at it and they were like, no. Because the way that or like at least my Surface was constructed is you can't like open it up and take out the card and put it back in. It's all kind of soldered in onto the computer. And so trying to take it apart and take out this one chip and put a replacement in would break everything else. And so that's an example of encapsulation, where this computer is an atomic unit. And so if one part breaks, then, oh well, like you can't take it apart. And so that's the sort of mindset that we want to take into working with objects with encapsulation. And it'll also show up in how we use like private versus public members of a class. And so for abstraction, so let's say that we want to write a method that counts the frequency of things in an array. So that's fine and good. If we're counting the frequency of like words in a sentence, we can split a string into a list of strings and then go through and count how many times does this word appear? How many times does that word appear? And so on. But that's fine for a sentence, but what if we've got a list of integers? Or what if we have a list of something more complicated, like a list of houses? How many times does like one house appear? You need to have more than one method in order to have methods for all these possible types, right? Because you need to say in the parameters, here's what kind of thing lives in the list. Abstraction will solve this problem for us. So abstraction lets us work with things generically. We can define a generic type that will allow us to kind of rise above that and use more general methods instead of specifying like, this is a method to count the frequency of strings in a list. This is a method for us to count the frequency of integers in a list, and so on. So we don't need to do all of those. We can abstract and think generically. And my analogy for this is like, let's say I tell you, install Eclipse on your computer. Everybody's computer is different. You've got different operating systems, different manufacture years, and different chips inside your computers. And so depending on which chip, you have to install a slightly different version. But in general, the solution for this is, here's the link, pick the one that works for you, and then download that. So the abstract way of telling you to install Eclipse is give you a link, and then you decide which one you need based on your machine. Inheritance, we'll talk a whole lot about this. It lets us extend the functionality of an object, and it lets us create new types with maybe different properties or slightly changed properties than the original. And so my analogy for this one is, let's say I want to open a document on another computer. If I've got Microsoft Word on this one, but my one at home doesn't have Word installed, then I have to use Pages. And so when I say open this document on your computer, you have to like modify or extend the rules of, oh, I need to open this document in a word processor. I'm going to do what I know how to do. So even if it's not exact. And then polymorphism is all about if there's a reference to multiple types, then it selects the right one. And so for the most part, we can guide this along, and the Java compiler luckily handles a lot of this for us. The analogy for this is if there's options, you choose the right one for that situation. So like you can use Pages, Word, or Google Docs, but if you're doing collaboration, then maybe you choose Google Docs. All right. So those are our 4 principles. Encapsulation, which is hiding stuff. Abstraction, which is kind of rising above. Inheritance, which allows us to send information onto other classes. And then polymorphism, which is selecting the right one out of the options. Question. Object-oriented programming. All right, other questions? These 4 words might show up on an exam. Maybe. All right. So we also have to talk about some definitions in order to get us places. We'll talk about the definitions, and then you'll see me use them in action a lot. So this is kind of just to orient ourselves of here's how the terms that we use work. So I just realized I haven't opened Eclipse yet. So we'll do that and let that think about it. So far we have been working with classes, where we create a new class and that creates a .java file. And so a class is a file that contains code for a reference type. And this is true for all the classes that we've written so far, even though we're doing just scripting so far. So a class is a file that contains code for a reference type. This can be either we define it, so like we did our smart house example, or Java wrote this class. So like string, ArrayList, or scanner. Those are classes. They've got files that contains code for this reference type, so for the string reference type. And a class has members. It has fields, methods, and constructors. An object is a concrete instance or occurrence of a class. So like before, there's an idea of a red Yeti mug versus this is my red Yeti mug. So like it'd be different from like go to Ace Hardware and buy a red mug. It's different because like mine's got a label on it. Mine has like the tea that I drink in it. So yeah, it's a concrete instance. A type, a reference type, an abstract data type. Remember, Java likes us to be explicit with what type our variables are. So we've got our 8 primitives, and then everything else is a reference type. We also can call it an abstract data type, and this is a unit that's used for data storage and processing. And so it's got fields, methods, and constructors, and it's defined based on the code in the class.
Is it still the same type if it lacks one of a field method constructor?
Yeah, so the having field methods and constructors is not technically required. It depends on the application. So you don't have to have, like we've defined types this whole time. Like if I go to Eclipse, I ended up in Git perspective somehow. So like we defined a secret garden reading class. Outside of this, we can say like secret garden reading dots, I don't know, find words. And we can give the different arguments that we need to. Secret garden reading is a type. So we've defined the class where'd that file go? So we've defined the class, public class secret garden reading. That's the file, secretgardenreading.java. And then we've got the type, which we can use here. Secret garden reading, we've defined a reference type. And it's got methods. That's a method. Find words is also a method that live in the class in the type that we've created. This is a picture I found on the internet for what an abstract data type is. And it basically provides, like we talked about this like atomic unit. And so this is sort of what we're constructing, where we're doing something in our application where we want to use all this information. And then with our abstract data type, we've got public things that the user is able to access. So like in our secret garden reading type, there's a public method find words. And so we're able to access that and use it in another file. We can also have things be private, so things that we don't want the user to be able to access directly. And both of those get their information based on our fields or our data structures of how we actually represent the things that we're trying to keep track of. How we represent our properties, those are data structures. And so those are going to be our fields. Okay. So these are our fields. All right, so when we've got a class, our class has members. So let's say we're talking about our smart house. Our smart house is going to have members. It's going to have what are the lights? It's going to have the turn off the lights, lock the door, properties, behaviors. And so members are part of the class that are defined in code. And those members include fields, methods, and constructors. Those are the three types of things that a class has. Those are the class members. Fields, remember for the smart house, we talked about like, here's an array of all the lights. Here's a Boolean for are the lights on or are the lights off? Properties, things that we keep track of. Those are called fields. And so those end up being variables that we declare in the class. So fields are variables. And so they're not variables that are defined inside the methods. So for example, in this test class, we've got a string S2. That's defined in main. And so S2 is not a field of this test class. In order for it to be a field, it's got to be defined outside of the methods. And so if we have we declare a variable outside of a method, but still inside the class. So inside these curly brackets, that's a field. So that's a property, something that we're going to keep track of. It's basically a variable that gets declared inside the class, but outside any methods. And so once we do that, then we are able to say like, oh, okay, for reasons because main is static. Really? That's surprising. Cannot make a static reference to the non-static field. Oh yeah, okay. So the reason is because that main is static. We'll talk about static meaning, but static basically means that we're not making an object in order to use this method. So fields are things that belong to, they're going to be members of an object. So when we use that object, then we can access the fields. If it's static, then we're not going to make an object, or we don't have to. Okay, so a field is a declared variable in the class. A method is a behavior that the type will be able to accomplish. It's something to do. So for our smart house, that involves turn on the lights. So the lights turn on. Turn off the lights turn off. Turn the thermostat up to 70 degrees. That's an action that can happen, something to do. And this shows up as functions inside the class. So those are methods. For constructors, those are a way to build or construct the object. So before that, we just have our blueprint, but when we have a constructor, then we can actually make the object. And so in practice, this ends up being, let's set up the initial values based on some parameters. And then later on, as we use the objects, the things change. Where did... Okay. I've got a packet for this one as well. Word is thinking about it. And now Word has ascended off of my dock. You doing okay over there? All right, while that's thinking about it, the packet's gonna have like fill in the definition and stuff like that. Okay, so we've got a class, that's the Java code. We've got a type. We've got an object, and a class has members, fields, method, and constructors. What are the members of a class? What are the three types of members? Fields, methods, and constructors. Great job. All right, let's look at an example. Okay, so we're going to look at a very simple class. We're going to create a type called int cell. And my specification is it's going to be a type that will hold a single integer. And so my fields, the things I'm going to keep track of, my property, will be the actual integer. And then my methods will be to get it and set it and print it. So I've got one field, three methods. And so the idea here is I've got some data, and so I'm going to have my field, and then I'll have a method get, a method set, and then a method to print, which in Java is special, and it's called toString. Okay, so let's write this. So I'm going to make a new class. And I'm going to put it in, we're in a new unit, so I'll put it in U4 OOP for object-oriented programming. The type name will be int cell, and I will not add a main. Okay. So this is going to be a very simple type that's going to store an integer. So I'll have a field. I'll call it the int. And for my field, I'm just going to declare it. I'm not going to say my int equals 4 or something like that. I'm just going to say I will have a variable, and that variable will be called the int, and the type will be int. And then I'm going to have methods, which include get, which will just return the int. So I need other things for my method signature. Remember, method signatures like public, static, return type, method name. So public makes sense for this to be public. I want other people in other files to be able to access this. Do I want it to be static? No, I do not. Because static involves having a controlling object. And so for this case, I want int cell to be that atomic unit where someone refers to an int cell object and only references that object. And so I do not want to make this method static. However, I do need a return type. And so if my field is an integer and I want a method to get the integer, what should my return type be? Integer. And so once I give it the visibility and the return type, then we're good. Okay, so I also want this one to be public. And so then I'll have a method set where I'm assuming that someone wants to give me a new integer to overwrite the one that I already have. And so I'll call that x, and then I can say this dot the int is equal to x. What should my return type be? Void? Does anyone have any other guesses? Yeah, so this is a case where this is like a designing question of when the user is going to set a new value, do we want to, I don't know, give them back the new value? Do we want to give them the old value? Or do we just want to be like, okay, you did it, I have it, and I'm not telling you anything else? That's a decision that we can make. I will tell you, typically, we call these types of methods getters, and typically we call these types of methods setters. Computer science are great at naming things. And typically setters are void return type. So typically we don't return anything. All right, that's our setter. And then we'll have a string method that doesn't take any parameters, but just returns, I don't know, this dot the int. All right, so that's our, let's see, what's this? Cannot convert from int to string. Oh no. Let's see. Okay, so we can't convert from int to string. So like, let's say none of these so this is a case where we have to use our critical thinking skills when looking at this error, where the two quick fixes are change the method return type to int, where this is a special Java method. And so if we change the return type to int, it's not going to be the special Java method anymore. Like the toString signature needs to return a string. The other option is change type of the int to string, which if we do that, then it changes the type of our string, but it also breaks everything else and everything else that we have designed. And so none of those options are good. So there's an option to like use the capital I integer wrapper type to be like, here, convert it to a string. So that's an option. I'll comment that out as one option. Another option is if we want to add other things, we can say the int is, and then when we concatenate like that, then Java is happy that it kind of does this work for us when we concatenate it like that. And so the issue here was that the return type is string, and we were giving it an int, and it's like, you've given me an int, I have to convert this to a string. What do I do? And so it doesn't know what to do. And so we have to be nice and give it more information. All right, so let's check our specification. A type that will hold a single integer. So we have not given up our principles and converted our int to a string. We've got a field of the integer. We've got a getter method. We've got a setter method. We've got a method to print. Sometimes other places in other books or on the internet, you'll see that like retrieval methods or accessor methods. You'll see them called that. It's also, they're just getters, right? So it's just, I want to get the thing that you're storing. And similarly, we can replace things or we can mutate the variables that we already have. The mutator methods are just setters or changing the state of fields. And we print. So great. So we're done. So we've done that step. Now the next thing is let's write a driver file. So we don't have a main method because we want to have our driver file separately. So we're defining a type and we generally want that to stay on its own. And when we want to actually do scripting and run code, we'll have a separate driver file. And I want to see if we can, well, okay, that's it, what it is. I want to see if we can access that int directly. All right, so I've got this file. Let me make a new file. And I'll call it int driver. So typically driver files, you'll add driver to the end or maybe demo or something. I'll do driver. And I will give it a main because I want to do some scripting here. And okay, so I need to set up my object. And so I have declared with using the type that I just defined. I have instantiated, so creating some space in memory for this variable x, which has type int cell. And let's see if there's anything in there. So if we print x, and then we run it, who thinks, first of all, talk to your neighbor. What do we think is going to get printed? So if this is what we return, what's going to get printed? Talk about it.
Yeah, I think it's just.
Yeah, we have int, and we have a public method that goes return the int.
But if it's true, and it's the other, you don't think that's not.
Maybe it's gonna return the. My, does it assign it a zero value? 'Cause
I don't know.
All right. So I think we've got some options. Either it prints the int is, and then nothing else. Here, let me copy this. The other option is the int is maybe 0 or some other number. maybe? Okay. Let's test it. Interesting. Okay, so the other thing that we don't have in our class, remember, what are the three kinds of members that the class can have? Fields, methods, constructors. So we've got a field. We have more than one method. We don't have a constructor. So that's just something to think about. So what it does for us is it has initialized this variable to 0 for us. We didn't do that, right? We never said the int equals 0. So that's interesting to note. Okay, but the question that I really wanted to know is, could we say x dot the int? So control space. Should have done the print statement before I did that. So classes, so we've got a variable x. What type of thing is x? It is a variable. What is the type of the variable? Int cell. Yeah. So the type of the variable goes before the name of the variable. And with variables that are objects, we can access methods. And so we can access methods. We can also access fields if we're allowed to. And so here we are allowed to. And so the question here is, maybe I have stored the I don't, it's been forever since I read like Hitchhiker's Guide to the Galaxy, but like the answer to life, the universe, and everything, 42. Maybe I want to say x dot set to 42. And now I want that number to be secret. I don't want to tell anyone what the answer to life, the universe, and everything is. But doing this, if it allows me to do this, then I can directly access that variable. I can directly access the field that's stored in X. And so maybe I don't want that to happen. Maybe I want that to be secret. And so the way we fix that is with visibility. So the options that we have for visibility include public, private, or nothing, which is package visible, and protected. And so public means anyone in any file can access this directly. So for example, let's look for something that we defined over here. Where was it? Okay, so max of A and B. It's a public method that lives in the more Java class. And so over here, if I wanted to, I can say, whoops, I accidentally deleted that. I can say more Java dot max of 1 and 2. It imports it for me so that I can do that. But max is a public method, which means I can do that. So I'm all the way over in int driver in a separate folder, and I can directly access this method. That's what public lets us do. Private means that nobody outside this class can directly access it. And so that's what I'm going to do for my int cell. So the other option is package visible. So if I don't have public or private, and I just have like the int, so there's no visibility modifier, that's package visible. And that means that anyone in this package will be able to access it. So that's why I can access it in this package. If I am over in let's see, test is in another package. So if I do so I'm going to make this class, I'm going to import it because it lives in another folder. And then I can say x dot the int, or I can try, but it says the field int cell dot the int is not visible. So this is a file that lives in another folder, another package. And so since the int is package visible, it's only visible to things inside this folder. So int driver.java, good. It can access it directly. Test.java, however, cannot access it directly because it lives in another folder. And so this is something to consider for you as a designer of, do I want the user to be able to play with this directly? Sometimes the answer is yes. Sometimes the answer is no. And so let's say that I don't want anyone outside of this int cell class to handle the variable directly. I only want them to use the methods to change things. In that case, I would make it private. And that just goes before the variable type. And that goes when I'm declaring it. And so I don't need to say it's private anywhere else. And you'll notice once I do that, if I go back to my driver, now this line gives me an error saying that the field int cell dot the int is not visible. And so because I've made it private, and so it's not visible even to other files in the package. So now it's truly a secret. Of course, it's not actually a secret because I can, so if I do sys out of x, I can still say, I can still get, like, here's the value of it. The only thing is just how I use it. So I can't access it directly now. But with my methods, I can still access it. I can still modify it. I can still print the state of it. I just have to use the variable as that atomic unit in order to do that. Okay. So yeah, so far we've done class and method visibility. Fields can have visibility too. And so we've made it private and we've tried to access it and we can't. Questions so far? Okay. So we had a thing where we created this object that we call X. And we said, okay, create a spot in memory for it. And it did something for us that we didn't expect. When we printed it, it just prints 0. So it, behind the scenes, without our knowledge, assigned a value. It initialized our field to be 0. And so that's because we didn't have a constructor. So when we instantiate an object, there are some default things that happen. So yeah, so that's what happened, where if we don't have a constructor defined, actually, I'm going to change this. Oh no, where did you go? Why did you go all the way over there? Hold on, let me fix this. Use as main display, here for built-in display. There we go. Okay, I deleted the word method there. because a constructor is not a method. So what are the three members of a class? Fields, methods, constructors. And so constructors are like separate. They look a lot like methods, I'll give you that, but they are technically separate. And so constructors, if we don't have anything, the compiler will go through and initialize all your fields, all your variables. And what it does is if you've got primitives, those get initialized to 0 or false if it's a Boolean. And if you've got reference variables, like maybe you've got a string, it'll initialize that all to null. So if you don't have a constructor, that's what the compiler is going to do for you. If you want anything else to happen, then you need to have a constructor. And so for our case, maybe it does make sense to have our int cell be like have no constructor and just initialize to 0. Maybe that makes sense for us. But in case we don't, in case we want to have something different happen, we've got to define it. And so a constructor looks like, do I have that slide for that? No, why don't I have that slide? That's a me problem. A constructor looks like we have some visibility or maybe no visibility. And then we have the class name with any parameters in parentheses. And so the difference between this and a method is A, we don't have a return type for a constructor because a constructor is not a method. So we don't have a return type like void. So that's a no-no. And the class name has to match the name of the class, which has to match the name of the file. And so maybe my constructor looks like I want to take in the input of what does the user want the int to initially be. And so I'll set that up. I can have more than one constructor if I want to. So let's say I want to have two options. One option is where they give me an integer to initialize, and the other is a 0 parameter constructor where I don't want any input. And so I can, for that one, I want to say, let's initialize it at 0. This is a choice I just made, where I decided that if I'm given no input, I want my variable to be initialized to 0. Maybe I want to say like negative 9999999. That's a choice I can make. And so this allows me over now in my driver. So I've got two constructors. This is an example of polymorphism where I'm going to have two constructors, one of which is going to call that 0 parameter constructor, and it's going to print 0. The other, let's define y. And I'll give it 1, 2, 3, 4 instead. And so this means that it's not going to get initialized to 0, and then later I have to go in and say something like y.set 1, 2, 3, 4. It eliminates the need for me to do that line. I can just do that all in one line when I construct it. So let's print y just for fun. Great. So it initialized x with 0, and then it initialized y with 1, 2, 3, 4. And the reason that it did that is from the constructor that I wrote. So this is all about understanding what does the compiler do automatically, and do I want to do anything different? So automatically, primitives get initialized to 0 or false, and references get initialized to null. Anything other than that, I have to define a constructor. Constructor name should be the same as the class name. So if I said int cells instead, then this gives me an error. And it now assumes that it says return type for the method is missing. So because the name of this does not match the name of the class, which does not match the name of the file, it assumes, oh, you're trying to do a method and you haven't put in a return type yet. Constructors don't have a return type. So if the name of this constructor matches the name of the class, which matches the name of the file, we're all good. And then we don't need a return type. Okay, how's Microsoft Word doing? That's inheritance. I'll hunt it down. Turn to your neighbor. What are the 3 members of a class? I'm gonna move away from that slide. Does a constructor have a return type? Let's say I'm writing a class called capital B backpack, and I want my constructor to be public. What's the signature of my constructor? So yeah, so if the constructor is, here, let me plug my iPad back in. Yeah. So if I'm gonna have a class backpack, my constructor looks like public backpack. Do I need a return type? No. Okay, what other simple questions? Can I have multiple constructors for different parameters? So like, let's say this is if I want an empty backpack, or if I want to add something in, I can have a parameter in order to set up that backpack, to create it with something already inside. All right, so we've got setters and getters. Setters are something to change the state of an object, which is typically to change a field. We've got getters, which are to access or get a current field. So something about the state of the object. And then we've got combination lock. Okay. Trying to think. All right, let's talk about this, and then I will talk about this, and then I'll probably let you go a little bit early because next time we will actually do this. So let's think about a combination lock, like for your locker in high school or for your locker for the gym. It looks like this, and the way it works is you've got 3 numbers for the code, and so you turn it in succession, you turn to the first number, turn the other way to the second number, turn the other way to the third number, right? So there are 3 numbers that are inputted in succession, and the order matters. And so if you have, for example, like if you're, oh no, if your combination is 1, 2, 3, that's different from the combination 3, 2, 1. That's different from the combination of 2, 1, and 3, right? Those are all completely separate combinations. If your combo is 1, 2, 3, then inputting 2, 3, 1 is not going to get you into your locker. Fun fact, if you're in discrete math, we will talk about this. These are what are called permutations. So inputted in succession, the order matters. We don't want everyone to know what our locker combination is, right? You don't want someone to be able to break in just by like looking on the lock of, oh, your combination is 1, 2, 3. That's like, why bother at that point? So the combination is secret. When we construct this class, I want to have 2 options. One option is where I say, here's what I want my combination to be when I make the lock. So that's maybe like we order it from the manufacturer and say, set up a combination lock with the combination 5, 6, and 7, right? We tell them, this is how you set it up. The alternative is maybe you buy it from the store and it's initially just 0, 0, 0. And then maybe it's got like a key on the back and you can set it. So, but we want the combination to be secret. And so thinking of the terms that we learned today, yeah, what do we want that to be? So I'll have you talk about that in a second. Combination is secret, set it in the constructor. I'm going to want more than one constructor. The operations I want will be open the lock, close the lock, and change the combination. What are we going to need in order to open the lock? Like, if I'm approaching my locker and I've got a lock on there, what information do I need? Yeah, I need to know the code. So I need to know those 3 numbers. If I'm closing my locker, what information do I need? So this is the question, do I need the code in order to close the lock? No, so I can just like snap it closed and walk away. So, so I need the code somewhere. For close, I don't need anything. I can just do it. And then I want to be able to change the combination, and only if I know the current one, or maybe only if I have a key. So I would say that this part will be optional, but this part is required. So this is like my very broad specification. So I'd like us to take the next few minutes of pull out a piece of paper and try and sketch out what do we think this class is going to look like? What will be the fields, the methods, the constructors? So not worried right now about writing code. I'll have you do that in the next class. But given this broad specification, try and translate it more into what sort of code are we going to write. So talk with your neighbors, try and figure out what is this going to look like, and then in the next class, we'll actually code it.
Well, I think it's gonna look like a lot. Something with 3 constructors. Yeah, one's for open, one for closing for change. Or maybe it's instead of constructors, your methods. Move field that's just like what combo, that's all, that's all field you do.
Yeah, or I'm making
Oh,
one for
and then I think you might need a field for the combo, a field for a boolean saying open or close. And then I think that's only 2 fields, just underneath. Open is true, close is false. Is it? I think the operation.
I don't really know. I mean, I guess technically
It seems like constructors are just like methods that don't return anything.
Constructors aren't methods.
But it's not, but it seems like they're methods that don't return anything.
They look a lot like a method,
Yeah.
but I will push back that they are not methods.
Yeah. Oh, and then, we'll go with the method that I have for the open, where if it's the right code, they change it to boolean, because it's like, some false to true. And maybe a constructor for.
If it's open, because like you can see whether that's open, but like if you forget it off. Like, because you mean, because we're not living with shit, like you have to check what happened with this, but. So like, is this spot open or closed? So like, oh, it's so.
Yeah, so the constructor that always closes, the law.
Yeah, I mean, like that's, this is something I think. Open, close. I don't know to know that. See. Yeah, close. You couldn't really so. Right about open.
You have a method that. And then change the boolean. Right. That's the end. And a constructor that keeps the lock either open or closed, depending on what you want.
Yes, there's a way to like.
Reset that. The other constructors, yeah, you can set up a constructor to reset it. Like if it's if. It's a story. One. Yeah. If code is wrong, I can close it to error. And then. If open. Yeah, it's like. And once you have it open, how do you close it? Yeah, you want to do constructors for that or methods?
I think.
A constructor is only for setting up the object. Only for setting up, like, we're making a brand new lock. That's what a constructor is for. Anything that we're changing about the lock after we've created it is a method.
Okay.
That's how I was thinking. Oh. One constructor.
Yeah, one constructor is making a lock. And it's combo. That opens it. Well, you can define your field, and then you can define the fields being in the constructor. You can define like amp for combo.
Okay.
Reallocated inside of the structure. But it's the same thing.
Did it do it again? It did it again. Why? Okay. So I want us to, so we're gonna do a thing that is kind of a teaser for later. We are gonna draw what's called a UML diagram. And so this is going to be my combination lock. It's going to be a class called a combination lock. And what I'm going to do is I'm just going to draw like my blueprint of this is what I want my code to be. And so what fields, so let's have like this kind of be my fields. What do I want my fields to be? the code. Okay, how am I going to represent that? Streams, yeah. Okay, so yeah, so what is the code? So for this, it's like a number 0 through 39. Those numbers are ints. Okay. But there's 3 of them. How do we do that? Right? This is the tricky part where we have this specification of like, oh yeah, I'm gonna make a combination lock in code. But like how do I actually go from one to the other? That's the tricky part. Oops. Um, no, okay. So we've got the code that's somehow an integer, but 3 of them? So how actually like I want us to this is a part where like you are the designers. And so what are the ways that we could have 3 integers represented as fields? How do we store that information? An array, yeah. So an array is one option. Any other options? So the option so I'll have you do it and then I'll show you my version. My version actually has like um 3 separate fields. So like int num1 or num2 and num3. So like 3 separate integers. Which for a 3 number combination lock is manageable. And so again, these are like 2 equally valid ways of doing it. Like having it in an array, I think makes sense. Having it separately may be a little bit easier to get started with. But it is also a valid way of approaching it. So this is where like you are the designers really steps in. Okay. Let's talk about constructors. So let's say CL is my abbreviation for combo lock. What's the parameters of my constructor? First of all, what is the constructor doing?
Setting up lock.
Setting up the lock. Yes. And so what do we want? What's involved in setting up the lock?
Close.
Closing it. Okay.
Setting the comma.
Where do we get that information from? Input. Input how? Say that again. From the user in what way? Scanner. Okay, so this is a possibility. So I I agree. Yes, scanner can be used. I think for this it may be easier to not use a scanner and instead like just get it from the parameters instead. So like scanner question mark, or we can do like num1, num2, num3 as parameters. That's another option. Again, this is a design choice that we're making. So set the combo, which can come from the parameters or from the scanner, and close the lock. I think that sounds fine. What if we want the combination to be 0, 0, 0? I mean, we could give 0, 0, 0. There's also an easy way to do it. So there's the thing of the zero parameter constructor where if we don't define it at all, then it just sets it up for us. Or we could say explicitly, like if we have zero parameters in our constructor, then num1, num2, and num3 are all zero. So I'm gonna do that again. We can have a zero parameter constructor where we set the combo to be 0, 0, 0. And then, yeah, close the lock. All right. So I'm okay with the constructors. I'm okay with the field so far. Operation. If we want to open the lock, we want to, how do we want to get the code in order to open the lock? Yeah, again, this is like, we could use a scanner if we wanted to, or we could just have it be input as parameters or as arguments, right? Like, these are design choices. And so for simplicity, I'm gonna not go the scanner route. I'm gonna go the parameter route. But this is a choice that you could make differently. So and so open, what does open need to do? So it gets in the code, but what if the code is 1, 2, 3 and I'm given 4, 5, and 6? Do I open it? No. So what needs to happen? Ifs, yeah. Yeah, and so I need to check like this against, so check against the fields. And so then similarly for, well, for close, I don't need to do anything. I can just say close. And then also change combo as a method. Which we can talk about next time. Okay, so I'll let that pause for now, also because my computer is dying. Homework 2 is now due on Tuesday, so please take the time and get that done. See you at the lightning talks tomorrow if you want. It should be really good. Lots of people working on interesting projects. I think that's all the announcements that I have for you for now. So have a good weekend, and I will see you next time.
Thank you.